Today we want to talk about data frames. This is a follow-on to the discussion on vectors. A data frame is a rectangular array of data, and I'm going to emphasize the fact that it is a list of vectors, and they all have to be of equal length because the data frame is rectangular. A vector is a column in the data frame, and a row corresponds to some kind of unit of observation. You can create a data frame using the data.frame function. And here are three ways to do it. The first way is to call data.frame, and then within the function you create the vector name, which is Alice and Bob, and the vector age, which is 25 and 30. And if I look at df1, here's what I've got. The second way is to create the vector name and the vector age outside of the data.frame function. And then I create a data frame df.to by calling data.frame with just the names of the vectors as arguments. A third way is to just put the contents of the vectors as the arguments for the data.frame. And that would work, but it gives you some rather unwieldy column names. So I don't like that. And if I did it that way, I could fix the problem by saying that I want the call names of the data frame df3 to be the vector name, comma, age. And then I've got basically something which is similar to what I've created with df1 and df2. Okay, so it would be a good idea to stop. Well, actually, I'm going to give you a little exercise to work you through these things. So your exercise right now, and I want you to do this, is to create a data frame named students that contains the following columns: ID, name, and age, and fill it with the following data. The IDs are 101, 102, and 103. The names are John, Jane, and Jack. And the ages are 21, 23, and 20. Okay, now it is important that you stop the video and do this before you continue. Okay? Okay, you're back. So I assume that you have done this exercise. Now let me show you the solution. So ID is the vector 101, 102, 103. Name is the vector John, Jane, and Jack. And age is the vector 21, 23, and 20. And students is equal to the data.frame of ID, name, and age. And there is the vector, there's the data frame students. Okay? So the next exercise is really very simple, but I want you to do it. Use the str function to see the structure of your data frame. And again, pause the video while you do this, then come back and start it again. All right? Okay, you're back. So I assume that you have done this little exercise, and here is what we get with str, structure of students. And it tells you that it is a data frame with 3 observations of 3 variables. And it tells you that the first variable vector is an ID, and it is numeric. It contains 101, 102, and 103. And the second column or vector in the data frame is name, and it is a character vector, and it is John, Jane, and Jack. The third vector or variable in the data frame is age, and it is a numeric vector with values 21, 23, and 20. Okay. So there are two ways to do this, and I want you to see that they both give you the same result. And what I want to do is use the $ and the bracket operators, double bracket operators, to obtain the students' names as a separate vector. Verify that these produce the same result. So, okay, stop the video and do this, then come back and start the video again. Okay, you're back. I hope you've done the exercise. So names 1 is students, $ name. Names 2 is students, bracket, bracket, quote, name, quote, bracket, bracket. Names 1 is a vector which contains John, James, and Jack. And names 2 is a vector which contains John, Jane, and Jack. So they both gave you exactly the same result. Okay. Okay, so I want you to change the first name in James 1 to Joe and verify that the names in the data frame and names 2 have not been changed. That is, I just want you to verify for certain that these are distinctly different objects. And again, please stop the video and then come back and restart it again when you're done. Okay, you're back. So getting the first element of names to be set to Joe, its names bracket 1 is equal to Joe. And I look at names 1, and I get Joe, Jane, and Jack. Names 2 was not affected by the change in names 1. It was John, James, and Jack. And students' $ name, that is the vector within the data frame, students' $ name, is still John, Jane, and Jack. Okay? Okay, another data frame. I want you to create a new data frame, students 2, in the same format. And the ID values are 201, 202, and 203. The names are Tom, Dick, and Harry. And the ages are 21, 22, and 23. Then use the rbind function to add students 2 to students. Okay, so stop the video, get this done, and then come back and restart the video when you're ready to continue. Okay, you're back. So again, I create 3 vectors, ID, name, and age. And then I create students 2 with the data.frame function applied to ID, name, and age. And if I look at students 2, it looks a lot like students 1, or students. There we've got 201 is Tom, age 21. Student ID 202 is Dick, age 22. And student 3, ID 203, is Harry, age 23. Now, I want to add that data frame to students. So the new version of students is the rbind of the old version of students and students 2. Rbind stands for row bind. Now if I look at students, I now have both the first set of students, John, Jane, and Jack, and the second set of students, Tom, Dick, and Harry. Okay? On we go. The next thing is to create the vector major, and it has the values CS, IT, ME, CE, ME, and CS. These are all HIMSI majors. And I want you to add it to the data frame using the cbind function, making students 3. And then there's an alternative process that we could use to do the same thing. I want you to add it to the students data frame, making students 4, but this time just use the $ operator and verify that students 3 and students 4 are identical. Okay, again, as usual, stop the video and come back when you're done, when you're ready to continue, after you've done this exercise. Okay, you're back. So here's the vector major with the majors I asked for. And to create students 3, you cbind, that is, you column bind students and major. That is, bind the column major to the vector, to the data frame students. And here is students 3. And note that I've got the majors added. Another way to do the same thing is to start off with student 4 as simply a copy of students, then use the $ operator. Students 4 $ major is equal to major, and then I've got students 4, and it looks exactly like students 3. Okay? Now, I want to create a new data frame, mechanical engineers. It's a subset of students 3 where the value of major is ME, mechanical engineer. Use the bracket operator. In this case, there's only one bracket on the left and one bracket on the right. A single bracket, the single bracket operator gets you a new data frame, whereas the double bracket operator or the $ would get you a vector. Okay? So do this exercise, and when you're done, come back and start the video again. So stop the video now. Stop the video. Please stop the video. Come back when you're done. Okay? Okay, you're back. So here's mechanical engineer. Oh, I did it as a subset of students 4 instead of students 3, but they're the same thing. Then in the single bracket operator, this is a little bit complicated. You have a row specifier and a column specifier, and the row specifier is that the students 4 $ major is equal to ME. And that is a Boolean. And then you have a comma, and then you don't specify the second part after the comma. You don't specify the vectors that you want because you're creating a data frame. And now I've got mechanical engineers. And there are only 2 of them, Jack and Dick. If you left out this comma, then you'd get a syntax failure. Okay? Now we're going to learn how to do this very shortly with a tidyverse. And if you're thinking that this is kind of a cumbersome, awkward thing, I mean, you were talking about students 4, So why in the world did you have to, again, specify that students $4 major was part of students 4? It seems like sort of a redundancy. And we will get away from that in the tidyverse. It'll look much neater. Okay, but that's all for this lecture.